Hola, Algebra 2! Today we're going to talk about the hyperbola. The hyperbola, this is a picture of what a hyperbola looks like. We are going to be dealing with asymptotes. Again, asymptotes are invisible lines that our functions will, or not functions, but our graphs will never touch. Again, these are called asymptotes. Okay, invisible lines. We always use dotted lines to just to show asymptotes, because obviously we can't draw an invisible line, so we use the dotted line to symbolize that. Well, we worked with the ellipse last time. An ellipse, we said, one of the standard forms for ellipse was x squared over a squared plus y squared over b squared equals 1. Well, the hyperbola has a similar formula for this. The hyperbola looks pretty similar. The only difference now is that there's a minus there. So it's x squared over a squared minus y squared over b squared equals 1. Now, another key difference with this, between the hyperbola and the ellipse, is here we said a is always the bigger number. Okay? Always the bigger number. That's for the ellipse, but a hyperbola, a doesn't have to be larger. It's basically the denominator that comes first. That's the easy way of explaining it. It's the denominator that comes first when we are given this formula. Okay, the one that's not connected to the negative. It's the one that has the positive numbers in front. Okay? Well, the one other difference is that foci, okay, for an ellipse, we had f is equal to the square root of a squared minus b squared. Now the foci for a hyperbola is f is equal to the square root of a squared plus b squared. Okay? Now when we graph a hyperbola, we actually don't graph b. We're only going to plot a. And also, the one extra thing with a hyperbola that we don't have are asymptotes. Ellipses don't have asymptotes. Okay, so there's going to be two equations. We're going to go over both. It's going to be a over b times x. These are the equations of the asymptotes, the lines. Or y equals positive negative b over ax. Alright, so let's just do a problem here. And we'll graph it, and hopefully it'll make some sense. So, we have here 25 x squared minus 4y squared equals 100. Now, just like the ellipse, notice that both of these equations, it's equal to 1. Okay. By the way, there's one other equation here. This is also a hyperbola. Just like how the ellipse has two, the hyperbola could have two as well. So, but notice both of them end in 1. So we have to get this to be 1. And just like the ellipse, we're going to divide by 100. Divide by 100. So 25 actually goes into 100 4 times. So we could reduce x squared over 4 minus y squared over 25 is equal to 1. Now the question is which one is a, but remember with the hyperbola it's whatever comes first. So 4 in this case is a squared. So the way we find a is just square root it. So we know that a is 2. Okay, so this is one bit of information. The other bit of information is the foci. So let's find one focus is equal to the square root of a squared plus b squared. So here we have f is equal to the square root of 29. So there goes our focus. Okay, one focal point. And lastly, we need to figure out asymptotes. But here's the trick about asymptotes. If x squared comes first, for a hyperbola, this is the equation you need to use. Y is equal to positive negative b over ax. Notice we have 2 here. We have a over b, and then we have b over a. if x comes first, use the b over a. If y were to come first, then you would use a over b. So, in this case, we have y is equal to the positive negative. We know that a is equal to 2. 25 is in the position of b squared, so b would be 5. Take the square root. X. So that's all the information we need to be able to graph this. Okay, again, A, focus, asymptotes. So let's graph that. Alright. So A is 2, but notice A is underneath the x-axis. Therefore, we're going to go over 2, 1, 2, 1, 2. We're going to graph those. Okay? Plot those points. Alright? Now, the focus will always be on the semi-major. It always matches up with A. That's the one thing about the ellipse and the hyperbola that is the same, is that the focus will always match up with A. Well, F, the square root of 29, so that's between 5 and 6. 3, 4, 5, 6. So it's somewhere between 5 and 6. I don't have a calculator on me right now. 3, 4, 5. So I don't know what it quite rounds to, but I know it's between 5 and 6. Alright. And lastly, we need to plot our asymptotes. Now notice here that there's no or 0. When you do y equals mx plus b, we don't have a y-intercept here. That means it's crossing at 0. Okay? These asymptotes are going to be crossing at 0. So here's your rise over run, 5 over 2. Rise over run. So I'm going to rise 5. 1, 2, 3, 4, 5. That's, we should probably draw this to scale. That would probably be good. Okay, so 1, 2, 3, 4, 5. Over 5, up 5 over 2. Rise over run. Rise over run. Since it's positive negative, we're going to rise and go back 2 as well. So here goes our asymptotes. We can take this dot, go through the center, and make our dotted line. Okay? Same thing here. We take our dotted line, from this point, go through the center, and extend it. Okay? So there goes our asymptotes. And then we just draw the hyperbola. It goes infinitely along these asymptotes. So it looks like this. And you cross through A. Okay? We cross through A and go towards the asymptotes. And there you go. So we always want to plot. So 2, 0. This is root 29, comma 0. Negative root 29, 0. And this is negative 2, 0. Okay? And there you have it. So we're going to do more, but just for now, understand that A, again, is the first number you see. That's a squared, so let's take the square root of that, and you'll find A. The focus is a squared plus b squared, and then take the square root of that. And then the asymptotes, if x comes first, we do b over a. If y comes first, we do a over b. So let's try one of those, a over b's. Okay, so it says a hyperbola has vertices, so a new problem here. Has vertices at 0, positive, negative 4. Okay, and it has foci at 0, positive, negative 5. So we have to write the equation of the hyperbola, and then we're going to graph it. Well, again, the foci always matches up with A. So we know that's A, because they're on the same axis. But notice, since it's 0, positive, negative 4, we know it's going to be on the y-axis. So we say y squared over A squared, so in this case, 16, minus x squared over, but we don't know what b squared is. And again, the way we find that out is we know f here is 5. We say f, which is 5, is equal to the square root of a squared plus b squared. So now we need to get b squared by itself. So the way you get rid of root is square it. So let's cancel out. So we have 25 is equal to 16 plus b squared. Subtract the 16, you get b squared is equal to 9. So we're going to get rid of those. get rid of the b squared, and substitute a 9 in. So here goes our equation. So we finished our equation, but now the question is, how do we graph? Well, let's list our information that we know. We know that a is equal to 4. We know our focus, one focus is equal to 5. And our asymptote, remember, since y comes first, it's going to be a over b. So a, 4, over b, which the square root of 9 is 3x. That's the equation. Those are the equations of the asymptotes. So if we were to graph this, okay. Alright, so a is 4, and it's on the y-axis. That means we're going to go up 4 on the y-axis. 1, 2, 3, 4. Go down 1, 2, 3, 4. And notice our foci is 5. So go up and down 5. Because again, focus and the a are always on the same axis. But notice our asymptote is 4 over 3, or rise over run. Up 4 over 3. So we're going to do our dotted line that goes through the origin, through that point. Okay? Up 4, back 3. 1, 2, 3. And we're going to do our dotted line that goes through. Okay? And lastly, we need to draw the asymptote. And remember, it always crosses through a. Last time we made it look like this because a was on the x-axis. Now it's on the y-axis. Our asymptote looks like this. Our hyperbola looks like that. And again, it gets infinitely close to the asymptotes, but doesn't touch. So if you wanted to label, this would be 0, 5. That would be 0, 4. That would be 0, negative 4. This would be 0, negative 5. So that's how you draw the hyperbola. Okay? Good luck with that, and please, again, let me know if you have any questions in class. All right, good luck.